Sorry about messing up that derivation right at the end of class. I just kind of in a rush, and we all know what they say about haste. So anyway, I'd like to work through it right now and just show you that derivation, and I'll be really quick about this. But basically, when a ball rolls down a ramp, we used to say that up top it has PE, down at the bottom it has only KE, and we used to say stuff like the PE turns into KE, the MGH turns into 1 half mv squared, the V is equal to root 2 GH. But the reality with a rolling object is that it's more complicated. There's also rotational kinetic energy, right? So, if a frictionless block slid down a frictionless ramp, it would just be pure PE into pure KE, but not if it's rotating. If it's rotating, there's also rotational KE. So up at top, there's gravitational PE, and that turns into rotational energy and translational kinetic energy. Okay, so the MGH turns into and is equal to 1 half I omega squared plus 1 half m times v squared. Okay, well, what we should do right off the bat is let's substitute omega out of there, right? So we know that omega, we know that velocity, tangential velocity is radius times angular velocity. So angular velocity is translational velocity over radius. So where I see omega, I'm going to put v over r. Okay, well, so mgh is equal to 1 half of I, which, since it's a sphere, it's 2/5 mr squared. So I look on my chart, I see that spheres have a moment of inertia of 2/5 mr squared. Omega squared. Okay, well, omega squared is v squared over r squared plus 1 half m v squared. Okay. And next, I see right here that in the same term, I have r squared 2/5 mr squared. That r is in the numerator. Over that r is in the denominator. Same term, that times that. So these two r squareds cancel each other out, right? And so what I have now is mgh equals, let's take a quick shortcut here because it's straightforward. 1 half of 2/5 is 1/5. And that's m times v squared plus 1 half of mv squared. Okay, well, so I have a fifth of an mv squared plus a half of an mv squared. Well, so we just have to get those denominators to be the same lowest common multiple, and that's going to be 10. So mgh equals 1/5. Well, what's 1/5 in tenths? 2/10 mv squared plus 1 half in tenths is 5/10 mv squared. So mgh is 2/10 mv squared plus 5/10 mv squared. That's 7/10 mv squared. Let's divide by 7/10 m. Let's just divide everything by m right now, right? Let's divide everything by m. That m goes out, that m goes out. And so I have g times h is 7/10 v squared. Is 7/10 v squared. So let's multiply by the reciprocal, right? So, we could say gh over 7/10 is v squared. I mean, let's go ahead and say it. Gh over 7/10, 7/10 is v squared. But let's multiply by the reciprocal. So dividing by 7/10 is the same thing as multiplying by 10/7. So v squared is 10/7 g times h. So how fast does a ball get going, a solid sphere get going, if it is released from rest at the top of a ramp? How fast does it get going? Not root 2gh, but root A little bit less than 2, because some of that energy is not in translational motion. Some of that energy is in rotational motion. So there's the proper derivation for the formula. That's how I would figure out how fast a ball is rolling down a ramp. There it is, right there. Not so bad, really, when you do it properly. Alrighty, guys, have a great day.